Hello, thank you for watching this video. So in this video we're doing question 9 of May-June 2021 question paper mathematics paper 1, and these are cubic functions. So I'll read our statement and you have the drawing here, and then proceed to answer the questions that follow. Okay, so question 9. The graph of f is sketched below. So here's the graph of f. I've sketched it here. A and B are turning points of f. So you have your A and B. They are the turning points of f. C is a point on f. So you have another point C, which is a point on f with these coordinates. Right? Okay. So I don't think I need to explain this. So you have a cubic function here. Right? You are given the equation of your cubic function to be that. And then you are told that your A and B are the turning points of this cubic function, and you're told that C is some point on this function f. So here's C. Straightforward. It doesn't need to be analyzed. So 9.1. Determine the coordinates of A and B. So they want us to find the coordinates of A and B. What is A and B? So we have A here and B here. As we're told in the statement, A and B are the turning points of f. So we're told that A and B are the turning points of this cubic function. Done. So what do you know at the turning point? So you know at the turning point, your gradient is 0. If you draw a tangent here at the turning point, it will be a horizontal line like this. So the gradient of this function of this line is 0 here. If you draw all the time, when you draw a tangent on a turning point, it will be a horizontal line like this with a gradient of what? Of 0. That's what you need to know. At the turning point, the gradient is 0. So which means if you draw any tangent at the turning point of any function with the turning point, the gradient will be 0 there. Done. So now, since we know this gradient at the turning point that is 0, what can we do with it? So now, as you are doing calculus, right, your derivatives, you know that a derivative, the derivative of a function gives you the gradient at a point. So if you find f prime at x, so what this tells you, f prime at x, which is the derivative of a function, gives you the gradient at a point, where your m is the gradient. So if you find the derivative of f, right, it gives you the gradient at a point. So now, we know that f of x is equal to 2x cubed plus 3x squared minus 12x. This is our f of x, right? So let's find the derivative of this, which is f prime. So f prime and x is equal to, so how do you derive? Say 3 times 2, 3 times 2, which is that 3 there. X, and then from that 3, you subtract 1, right? Plus, what else? 2 times 3, so you have 2 to 3. This 2 is the one multiplying the 3, the coefficient of x squared. Then you have x raised 2 minus 1, right? Minus, so you have 1 here. So you have 1 times minus 12. This is minus 12. X raised 1 minus 1. That's how you derive, right? So f prime and x is equal to, this times this, 3 times 2, that is 6. X, 3 minus 1, you have squared there. Plus 2 times 3, that is also 6, right? X, 2 minus 1, you're left with 1 minus 12. Right? So, this derivative here, f prime, gives you a gradient at a point. If you substitute any point here, which, let's say for example, if you substitute x is equal to 2 here, then you will get gradient at x is equal to 2. That was an example. So I'll wipe this away. So, f prime at x gives you the gradient at That's what that does. It gives you the gradient at x, right? But at this point here, you know that your gradient is what? Is 0. And you know the gradient is also 0 here as well. So we have a situation where f prime is equal to 6x squared plus 6x minus 12 is equal to mx, which means the derivative of f, which is this, gives you the gradient at a point. But at our point, we know what the gradient is. We know the gradient is what? Is 0. We know at our point that our points A and B, the gradient is 0. So which means you substitute your 0 there and try and find the value at which our gradient is 0. So we're tracing back, we say, we now know that the gradient at our point A, at our points A and B is 0. So if we know our gradient, our points A and B is 0, we want to find what are those points. How are you going to achieve that? You say, okay, I know that my gradient is 0, which means my m of x is 0 here. So we have 6x squared plus 6x minus 12 is equal to 0. So if you're looking at this, if you're looking at question 1 situation, you're solving a quadratic equation. So what do you do? Maybe divide by 6, divide by 6, divide by 6, divide by 6. You're left with x squared plus x minus 2 is equal to 0. So from this point, you know how to solve your x. You can factorize or use a quadratic equation, quadratic formula. So I'm going to factorize. So open my brackets, equal to 0. What do we do from here? So okay, we have x here, we have x here, we have 2, we have 1, we have plus 2, we have minus 1. Right? These are our factors. Okay, you can use the quadratic formula from here. So your x is equal to minus 2, or your x is equal to 1. These are the values these are your x values, right? So 1 belongs to B and the other belongs to A. So the negative 1 belongs to A. So the coordinates of A, so they wanted the coordinates of A. So you have the x coordinate of A. The x coordinate of A is minus 2. The x coordinate of B is 1, right? So to find the corresponding y values, you substitute your x values from your original equation, right? So you have that f as a function of x is equal to what? 2x cubed plus 3x squared minus 12x, right? So now you have the x value, right? You want the corresponding y value, which is f of x, f at 2, and f at minus 2, sorry. So f at minus 2 is equal to 2 into minus 2 cubed plus 3 into minus 2 squared minus 12 into minus 2, right? And then you can punch that in your calculator and see how that goes. So we get that f at minus 2 is equal to 20, right? So we have our coordinates. Now we have the x, we have the x and y coordinate, which is what? Our x coordinate is minus 2 and the y coordinate is 20. Done. Then now we go to the next one. So these are coordinates of A. So now we want the coordinates of B. We do the same thing. We say, okay, we know our x at B is equal to minus 1. So we're going to find y at 1, which is equal to 2 into 1 squared, right? Cubed. Plus 3 into 1 squared minus 12 into 1. So what do we have? This is 2, this is 3, this is 5, minus 12. So f at 1 is equal to minus 7. That's what it is. So your coordinates is 1n minus 7. We're done with this question. So from here, we go to the next one, which is 9.2. Okay. So now we're going to do 9.2, right? Determine for which values of x will f be concave up. So they want to find what are the values of x will this graph be concave up. So what do they mean concave up? They want to know. So if you can see from here up until somewhere this area, your graph is concave down, right? It is concave down, which it have this shape like this. And then from this point going down, it's concave up, it just have this shape like this. So that's what we call concavity. So from somewhere here to this point, it is concave down. From somewhere here going this way, it is concave up. So we call this, so we call the point where our graph changes concavity the point of inflection, right? So some point somewhere, maybe somewhere here, I don't know. Our function f changes concavity. It changes from being concave down to being concave up. So they want us to find what are the values for which our graph is concave up. So, but what we need to find our critical point, which is the point of inflection. So the point of inflection is where this graph will change from this concave down shape to this concave up. That's what we need to find first. How do we find the point of inflection? The point of inflection, you can find the second derivative, right? Equate it to 0 and then solve for x. Then you'll find the x coordinate of the point of inflection. But if you have the x coordinates of your turning points, you can use them as well. So you can say, okay, the x coordinate of the point of inflection will be equal to x coordinate 1 of the turning point plus x coordinate 2 of the turning point divided by 2. That's what you can do. So we have found the x coordinates of the turning points. One was -1 and the other one was 1. Sorry, the other one was -2. The other one is 1. So now my x coordinate of the point of inflection is equal to x coordinate of a turning point number 1, which is -2, plus x coordinate of the turning point of the second point, which is 1, all divided by 2. So your x coordinate of the point of inflection, where the concavity changes, is this and that is -1/2. So at -1/2, which is maybe somewhere here, let's say somewhere here, this is where our graph changes concavity. It changes from being concave down, having this shape, to being concave up, having this shape. 1/2. Here, from x is equal to -1/2 up to infinity, our graph will be concave up, because this is the point where our concavity changes, because this is the point of inflection. At the point of inflection, the concavity of the graph changes. So at this point, x is equal to -1/2. It changes from being concave down to being concave up. So this point is called the point of inflection. So, but they want it where it is concave up, which means they want it where it has this shape. So it starts here all the way to infinity. For all x values are greater than -half. So your x values should be greater than -1/2. Or your x should be in the interval -1/2 to positive infinity. So, which means it's concave up here, right? Where are the corresponding x values? It's all these values up to infinity. So this is what this thing means. So it looks like we're done with this question. We're going to 9.3 now. Let's read 9.3. Determine the equation of a tangent to f at C. Determine the equation of the tangent to f at C. So they're saying, let's suppose that we have a tangent here at C, right? Here's our tangent. So they want us to find the equation of a tangent. You know a tangent is a straight line. So we have the equation y is equal to mx plus c. What is m? M is the gradient, right? Which is M would be the gradient of this line. But this line touches our graph once at this point, C, because it is a tangent. So by definition, it touches it once. So what we need is, we need the gradient of that tangent. On a normal day, when you're doing your analytical geometry, you will say, I need 2 points to find the gradient of my tangent, right? But at this point, we only have one. It's only C, because our tangent only touches our graph at C. So how are we going to find the gradient? I said when I was doing 9.1 that the derivative gives us the gradient at a point. I said the derivative gives us the gradient at a point, which means we know that the derivative f prime at x gives us the gradient at a point, right? What was f prime at x? F prime at x was this thing here, which means it was f prime at x is here. It's 6x squared plus 6x minus 12 is called m at x. So m at x is the gradient at a point. So now we want the gradient where our tangent touches the graph. It touches at x is equal to 2. So we want the gradient at x is equal to 2. So we'll say m at 2 is equal to 6 into 2 squared plus 6 into 2 minus 12. That's what we're going to do. Then this will give us the gradient at that point, right? So I'll punch that on our calculator to find what the gradient at 2 is. So 6 into 2 squared plus 6 into 2 minus 12. So the gradient at our point C, which is have the x value 2, is equal to 24. That is our gradient. So we on this line we have y is equal to 24x plus c. We're only missing what? C. The coordinates of C, of the point that we're given C, are 2 and 4. These C are different. This one is the y-intercept, and this one is that point that we're given there. So we say, okay, we want to find the equation of a line, right? What do we do? So, okay, 4 is equal to 24 into 2 plus c. So 4 is equal to this and this is 48 plus c. So solve for c. C is equal to 44 minus 48. So that is minus 44. So your equation of a tangent is y is equal to 24, x minus 44. And you're done with this question. It's one of the easiest that you can get. So, thank you for watching.